Hello everyone, welcome to this video where we are going to dive into level rotation, which is a problem under array section of data structure on HackerRank. So in this problem, we receive an array and an integer, and we are supposed to apply a left rotation that number of time in this array. What does a left rotation mean? A left rotation is actually a shift of each element on the array 1 unit to the left. That means if I receive this as array, if I want to put one left rotation, 2 is going to be at a position here, 3 is going to shift here, 4 is going to shift here, 5 will shift here, and this one that was at the beginning is going to be at the end. And if I apply it one more time, this 3 is now going to be at the first position, this one that was here is going to be at the second position. So all of them are going to shift like this, and we are going to have this. That is why we are saying if we receive this as input with integer this, we are going to end up with this as a result. Now the question is, to solve this, you can loop through this element. Like if you have g equal to maybe 5, you can apply the rotation 5 times and you have the result. But is it not a better way of doing that? This. What is the better way? You know that you are going to perform a shift of 2, right? So if an element maybe was at position, let's say 5, the final position, let's say if an element was at position 5, the final position will be 5 minus 2, which will be equal to 3. So knowing the position of a given element, you can just compute the element minus the number of rotation, and you have the end position in the end result. Let us take an example. Let us take maybe this element 4. 4 was at position 0, 1, 2, 3. 3 minus 2 is 1. 4 should be at position 1 now. 0, 1. This is 4 at position 1. So by doing so, you know exactly what will be the position of an element given the initial position and the rotation. First thing. But there's something interesting. If I was at position maybe 1, my end position will be something like 1 minus 2, which is equal to minus 1. It doesn't make sense. We don't have minus 1 indexes. So for such element that are actually less than 0, what you should do is that you should do the element plus n. That's all. Why? Because the first thing is that you are sure that d is actually less or equal to n. So if it's kind of going out of the box, you need to start back at position 0 here, at the last position. So that is why you need to apply this. What will it give? That means if I was at position 1, I will have 1 minus 2, which is actually minus 1, plus n, which will give me, n is actually 5, which will give me 4. Element at position 1 was this guy. Where will it be at the last position, which is position 4? 0, 1, 2, 3, 4. So we know our logic, we know how we are going to code it. So let's dive into the code. So the code will be like this. We are going to create a vector of int that I'm going to call result with a size n. I don't have n, so with the size r.size. Once I have it, so I'm going to loop now all of the elements. And for each of the element, what I'm going to say is that I'm going to say I don't want to compute and put the if. So what I will say is that I will say new index. We are just going to call it new index is equal to I plus d plus n modulo n. Oh, n doesn't exist. Why is that? I think n is. So Here I can directly use the n. Here I can directly use n, and then here I will do it this way, and I'll say result of new index will now take half I, and then here I just need to return the result. So what I'm saying here is that I'm computing the size, first of all the size, because I realized that I need to use it many times, so better to do it here. So I'm looping from 0 till the end of the array, and for each of the element I'm computing the new index. And computing the new index is basically what I was saying. I'm doing the shift. Oh, I'm missing something. The shift is I minus d. So I'm doing the shift I minus d, and I know that if I minus d is actually positive, the I minus d modulo n will always return the I minus d. So if I minus d give me maybe 2, and if the size of the array is 5, 2 modulo 5 will always give me 2. But if it's negative, I will need to add the n, right? And then if it's negative, I add the n, it will be now something positive, and the modulo n will still pass. But what interesting is that if it's positive and I add the n, it will exceed the n. So that's why, to combine all of those scenarios into one line, I'm using this. You can also have a condition here, like you compute the I minus d, and then you say if I minus d is actually negative, you append it to n, you add the n. Let me submit this and see what it gives. Everything is going perfect. So if you're not comfortable with this, what you can do is that, what I was saying is that you can say new index will take I minus d, right? And you say if new index is actually less than 0, you say new index plus or equal to n. Exactly what we just described here. If it's less than 0, that means the element is going to start at the end of the array. So you do it this way. By doing this, you are doing exactly what we were doing previously. It's better to know different approaches because it kind of gives you more tool to approach problems. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me your point of view. I'll be really happy to interact with you regarding this. Don't hesitate to like, subscribe, and share. Do not miss what we are doing here. We are really in our way of posting every day, solving new problem, sharing technique. So see you on the next video. Ciao.